few people have asked about the questions with geometric figures, and here's an example of this. Really, these geometric figures are just another pattern, okay? So if you look here, this is, I'm going to write over here the terms as soon as I can. Let's see here. So we're going to have the terms, and then we're going to have the number of triangles. Okay, so in the first term, you'll notice, so we have terms currently 1, 2, and 3. In the first term, we only have one triangle. In the second term, we have 1, 2, 3, 4 triangles. In the third term, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9 terms. So if we look at the numbers based on the terms, you'll notice that if we want to do an arithmetic sequence, that's where we add the same number each time. Well, here we added 3, here we added 5, so it can't be an arithmetic sequence because we're not adding the exact same number each time. So let me get rid of that. So a geometric sequence is either raising a value to a power or multiplying something each time. There's nothing that we're really multiplying here each time, but one of the things about this pattern is if you think about it, 1 squared is 1. 2 squared is 4. 3 squared is 9. So what we're doing is we're going to take the term and we're going to square it. So if we want the 100th term, in this case, we're going to do this. And when we do this, we will get 10,000. So this is the nth term. This is the 100th term. Again, these are just patterns just like the numbers were. So you kind of have to go through and try to find those patterns. Okay? Now I'm going to scroll down to this question so that we can look at it as well. And when we look at this question, we need to figure out possibly a pattern. Okay? So we have the first term, the second term, third term, and the fourth term. So these are our terms. We have 2 boxes. We have 1, 2, 3, 4, 5 boxes. We have 1, 2, 3, 4, 5, 6, 7, 8 boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 boxes. Okay? So as we do this, you'll kind of notice, check the arithmetic sequence first. So here I added 3. Here I added 3. Here I added 3. So what's happening is this is going to be an arithmetic sequence because we're adding the same number each time. Now we have to do something based on the terms. Okay? So if I take the term, so if I take 1, and I'm going to multiply it by 3 because that's how many we're adding. 1 times 3 is 3, but I need a 2. So how can I go from 3 to 2? I'm going to subtract 1. Let's look at the second term. We're going to multiply it by 3. That's 6. If I subtract 1, that's going to give me the 5. And let's do the third term just to show that it still holds. 3 times 3 is 9. Minus 1 is 8. So that's giving us these values here. So what we're doing is we're taking 3, multiplying it by the term, and then we're subtracting 1 from it. So this would be like our nth term here. Now if I try to do the 8th term, I'm going to do 3 times 8 minus 1. So 3 times 8 is 24 minus 1, which gives me 23 blocks. Now the last part of this question is a little bit different. It says, is there a figure that has exactly 509 square tiles? So in this case, we know what the figure is. We don't know what term it is. And it's going to equal the exact number of tiles. Well, in this case, we want 509 tiles. So we have to do a little bit of algebra here. And so I'm going to come over here. To get rid of this 1, I'm going to add 1 to both sides. That way these will cancel out, leaving me with 3n is equal to 510. And then I'm still trying to find the n by itself, so I'm going to divide, because this is multiplied, the opposite of multiplication is division. Divide both sides by 3, and I'm going to see that n is equal to 170 exactly. Now, if I had received a decimal, then my answer would be no, because it wasn't exactly that value. But since I've received that exact value here, this is telling me the 170th term will have 509 squares. Now go practice some out of the textbook, and if you need help or need the answers or something like that, please reach out to me.